I'm Anil Kumar, and here is another very popular question which we'll come across when solving right triangle applications using trigonometric ratios. The question here is, from the top of a 90-meter fire tower, a forest ranger spots a forest fire. The angle of depression from the top of the tower to the fire is 3 degrees. How far away is the fire? So what we are given here is kind of level ground on which we have a fire tower. Let's say this is the fire tower, and from here the ranger spots fire. So whenever we are given angle of depression, it is along the horizontal. That is why I've drawn that horizontal line, right? Now it's 3 degrees, which is very small, but I'll make a kind of a bigger angle, right? So it's not to the scale, but this angle is 3 degrees. Okay, that is what is important. So this angle is called the angle of depression. So whenever it is angle of depression, it is looking downwards but along the horizontal. That is how it is. Now in this particular diagram, you can see that the fire tower will be at right angles. So what we really know here is that the top of the tower is 90 meters. That means the height is given to us, 90 meters. So this angle is 3 degrees. Now as you know, horizontal and horizontal ground, they will be parallel. And therefore, the angle which we are talking about should also be at the base, right? So this angle is also 3 degrees, since it forms a Z pattern, you see, alternate angles between parallel lines. So that is the reason. So we have alternate angles between parallel lines, correct? And therefore we have, let's say, TOP. Let me write like this, right? So therefore angle TOP is also equals to 3 degrees. Now let's look at the problem once again. What do we need to find? It says, how far away is the fire? Now from where? Let's read it once again. From top of a 90-meter fire tower, a forest ranger spots a forest fire. The angle of depression from the top of the tower to the fire is 3 degrees. How far away is the fire? So that is the question for us. Now when the question is like this, we have to say that it is along the ground. It is from, that means fire will be, distance will be measured along the ground. So let's call this distance as D. Now it is important to specify it and then solve. For example, if you make a wrong assumption, but you have written this and you solve for D, even then you get marks in the test. That is kind of very important, right? So it is important to specify what you're trying to find. So we'll say, let the distance of fire from the tower be D as shown. That means we're talking about horizontal distance. You get my point. It is not from the top. So we have just ruled that out, right? So it really helps. It just tells you exactly what we're trying to find and what we are reporting, right? So we are saying that the distance from the base of the tower is so much, correct? Now, that becomes, if you now check from 3, this is opposite side, is it okay? And that one is adjacent. So whenever you have opposite and adjacent sides involved, we have to use tan, opposite over adjacent ratio. So that is the reason why tan will be used to solve this question. So we'll say tan of angle is 3 degrees for us, is equals to opposite side of 90 and the distance D, which we need to find. So distance D is equals to 90 divided by tan of 3 degrees. Let's use the calculator, find the answer. So 90 divided by tan of 3 degrees gives us 1717.30. 0.30, correct? So that is our answer, correct? Now the question is not very clear. The distance could be from top of the tower also, So let us call that distance, I'm just saying, right, let's say that is x, right? So let's be safe this time, and we'll say from top to fire is how much. Let's find that out. Now this one is hypotenuse and we are given the opposite side. So for finding this ratio we need to use sine. So we'll say sine of 3 degrees is equals to opposite side 90 over x. Now that gives x is equals to 90 divided by sine of 3 degrees. Is that okay? So we'll find this also and report both. We say 90 divided by sine of 3 degrees. And we get our answer as 1719.6. Units are meters, right? Here also units are meters. Now as you know, in these applications we are rounding distances to whole numbers or one decimal place. Okay, let's round this to whole numbers because in meters and a long distance. So let's round this to whole numbers and we can write this as 1720 meters approximately. That is from the top of the tower to the fire. Okay, so this is the distance from top to the fire. Okay, let's say this is what it is, and that is the distance, horizontal distance. This is horizontal distance, and this one is from top. So when things are not very clear to you, what you can do is, it just takes a minute extra. Write both the distances, right? So that keeps you safe, especially in the test. I hope that helps. Thank you and all the best.